During this lecture, we will get the information regarding different types of precipitation, mechanism of precipitation as well as impact of changes in precipitation patterns at global level. First of all, let us understand the general meaning of precipitation. According to meteorological point of view, precipitation is any product of the condensation of atmospheric water vapor that falls to the earth's surface under gravity. In general terms, the moisture falling on an area in liquid, vapors or frozen form is termed as precipitation. Precipitation occurs when a local portion of the atmosphere becomes saturated with water vapor so that the water condenses and precipitates. The main form of precipitation include drizzle, rain, sleet, snow, graupel and hail. Fog and mist are not precipitation but considered as a suspensions because the water vapor does not condense sufficiently to precipitate. Likewise, frost does not precipitate out of the atmosphere but rises from the ground, so it is also not considered as a precipitation. Generally, all precipitation types are hydrometeors by definition. Hydrometeor is an atmospheric water phenomenon which has at same point been produced due to condensation or precipitation of moisture within the Earth's atmosphere. Precipitation is considered as a major component of the water cycle. To understand the mechanism of precipitation formation, let us get an overview of the water cycle. The water cycle involves continuous movement of water on, above and below the surface of the earth, in which water moves from one reservoir to another, such as from river to ocean or from the ocean to the atmosphere. By the physical processes of evaporation, condensation, precipitation, infiltration, runoff and subsurface flow. Precipitation is mainly responsible for depositing fresh water on the planet. Approximately 505,000 cubic kilometers of water falls as precipitation each year, out of which 398,000 cubic kilometers of it falls over the oceans and 107,000 cubic kilometers over the land. The eco factor of the precipitation mainly depends upon season, wind, air pressure and temperature. Nowadays, global warming is causing changes in precipitation pattern globally. Now, let us study various types of precipitation in detail. In meteorology, rainfall types can include various forms of the precipitation falling to the ground level. Precipitation can fall in two phases, either liquid or solid. Let us discuss both the forms of precipitation in detail. Liquid forms of precipitation include rain and drizzle, while frozen forms of precipitation include snow, snow grains, sleet, hail, graupel as well as ice crystals. Let us start with the rain, the first. Rain is a liquid water precipitation in form of droplets that have condensed from atmospheric water vapor. It is a precipitation with diameter greater than or equal to 0.5 millimeter. Most of the atmospheric precipitation occurs as a rain. In the formation of rain, the smaller water droplets collide with each other because of air turbulence and produce larger droplets. As these larger water droplets descend, coalescence continues, so that drops become heavy enough to overcome air resistance and fall under gravity as a rain. Rainfall not only provides the suitable conditions for many types of ecosystems, but also provides water for hydroelectric power plants and crop irrigation. It has to be noted down that the intensity and the duration of rainfall are usually inversely proportional to each other. That is, high intensity storms are likely to be of short duration and low intensity storms can have a long duration. The second type of liquid precipitation is known as drizzle. Drizzle is a light rain precipitation consisting of liquid water drops smaller than those of rain. The droplet size is generally having the diameter of 0.02 inch. Drizzle is normally produced by low stratiform clouds and stratocumulus clouds. Precipitation rates due to drizzle are of the order of a millimeter per day or even less than that at the ground level. The next type of liquid precipitation is referred to as a freezing drizzle. It is a type of drizzle that freezes on contact with the ground or an object at or near the surface. Freezing drizzle generally occurs when drizzle forms in the air mass at or below freezing temperatures but warmer than -10 degrees Celsius or 12 degree Fahrenheit. Freezing drizzle is possessing drop diameter of less than 0.5 mm. The other type of liquid precipitation is the freezing rain. Freezing rain is made entirely of liquid droplets. The name is given to a kind of rain which only falls when the surface temperature is below freezing point. This occurs when raindrops become supercooled while passing through a sub-freezing layer of air, many hundreds of feet above the surface, and then freeze upon their impact with any object they encounter. Freezing rain is considered as notorious because it creates travel problems on roadways, breaks tree limbs, and cut down power lines. It is also known for being extremely dangerous to aircraft since the ice can effectively remold the shape of the airfoil and flight control surfaces. Now, let us see the solid forms of the precipitation. In this type, let us start with the snow first. Snow is a precipitation in the form of crystalline water ice consisting of snowflakes that fall from clouds. Snow crystals form when tiny supercooled cloud droplets having diameter of about 10 micrometer freeze. Since snow is composed of small frozen ice particles, it is a granular material. Snowflakes come in a variety of sizes and shapes. The shape of the snowflake is determined broadly by the temperature and humidity at which it is formed. At a temperature of around -2 degrees Celsius or 28 degree Fahrenheit, snowflakes can fold in a triangular shape. The most common snow particles are visibly irregular. Snow formation requires temperature below freezing. The process of precipitating snow is called snowfall. In mountainous areas, heavy snowfall accumulates when air is forced to ascend the mountains and squeeze out precipitation along their windward slopes, which in cold conditions falls in the form of snow. The second type of solid precipitation includes snow grains. Snow grains are the solids equivalent to drizzle. They have characteristics diameter of less than 1 mm and stick upon hitting a surface. Snow grains are actually white, opaque grains of ice that are fairly flat or elongated. The third type of solid precipitation is sleet formation. Ice pellets or sleets are a form of precipitation consisting of small translucent balls of ice. Sleet is melted snow that refreezes into a tiny ice pellet. Ice pellets are usually smaller than hailstones. They often bounce when they hit the ground and generally do not freeze into a solid mass unless mixed with the freezing rain. Another important solid precipitation is known as hail. It consists of balls or irregular lumps of ice, each of which is referred to as a hailstone. Like other precipitation, hail forms in storm clouds when supercooled water droplets freeze on contact with condensation nuclei such as dust or dirt. Hail has a diameter of 5 millimeters or 0.20 inch or more. Frozen drops. Hail is produced when large frozen raindrops, graupel, etc. act as accretion nuclei. In order for a hailstone to form, the accretion nuclei must remain in a cloud for a long time and thus travel a large distance within the cloud. This process is facilitated by strong updrafts of the type common within cumulonimbus clouds. Hail is most often associated with such clouds and is therefore more common during the spring and summer than in winter. Hail can occur during much warmer temperature regimes due to the process of its formation. Let us know the fourth kind of solid precipitation referred to as graupel. The term graupel is the German word referring to precipitation phenomenon that forms when supercooled droplets of water are collected and freeze on a falling snowflake, forming a 2 to 5 millimeter or 0.079 to 0.197 inch ball of rime. Graupel is also known as soft hail or snow pellets. Strictly speaking, graupel is not the same as hail or ice pellets, although it is sometimes referred to as small hail. The last type of solid precipitation is the ice crystals. Diamond dust, also known as ice needles or ice crystals, forms at temperatures approaching -40°F or -40°C due to air with slightly higher moisture from aloft mixing with colder surface based air. They are made of simple ice crystals that are hexagonal in shape. Now, let us try to understand the basic mechanism responsible for the formation of precipitation. Very specific conditions must occur in order for a cloud to produce precipitation. The principal mechanism that produces various types of precipitation is the uplifting of air along the sloping surface of a front and consequent cooling of air by expansion. In actuality, precipitation occurs when air is saturated and saturation occurs when air rises. Generally, three different types of precipitations are observed depending on the mechanism by which they are produced. The first is the convective precipitation, in which the air rises vertically through the self-sustaining mechanism of convection. Convection occurs when the earth's surface within a conditionally unstable or moist atmosphere becomes heated more than its surroundings, leading to significant evaporation. The second mechanism involves formation of stratiform precipitation. In this method, large masses over air rise slantwise under the effect of atmospheric dynamic force, which causes the layers of air to move over each other. Stratiform rainfall is caused by frontal systems surrounding extratropical cyclones, which form when warm air meets the cooler air. The third type of orographic precipitation or relief rainfall occurs when moving air masses encounter a rising slope of elevated land formations such as large mountains. The lift of the air up the side of the mountain results in adiabatic cooling and ultimately condensation and precipitation. It is believed that convective precipitation is generally more intense and of shorter duration than stratiform precipitation. Now, let us have an overview of the basic processes responsible for the producing precipitation. Condensation, collision, coalescence and the ice crystal processes are considered as three major processes for producing precipitation from clouds. Condensation in clouds is considered as an inefficient precipitation producing process which is unlikely to produce by itself. The collision coalescence process occurs in warm clouds. In this process, as cloud droplets are formed within clouds, they become electrically charged. The cloud droplets grow larger by sticking to each other because of collisions due to electrical attraction. As time passes, the droplets grow larger and larger. Finally, the droplets will grow large enough so that they can no longer remain suspended and will begin to fall. The ice crystal process occurs in colder clouds that exist mainly in the middle to high latitudes. Even in these extremely cold clouds, there is a presence of liquid water droplets referred to as supercool water droplets. These droplets are precipitated when the temperature of a cloud exceeds -40 degrees Celsius. Let us see how the intensity of precipitation can be measured. Precipitation intensity is determined either by rate of fall or by visibility restriction. The standard way of measuring the rate of rainfall is the standard rain gauge, which can be found in 100 mm plastic and 200 mm metal varieties. Rainfall amounts can be estimated by weather radar. Snowfall's intensity can also be determined by visibility. When the visibility is over 1 km, snow is determined to be light. Moderate snow describes snowfall with visibility restrictions between 0.5 to 1 km. Heavy snowfall describes conditions when visibility is restricted below 0.5 km. Now, let us classify the precipitation into different categories according to its amount. When classified according to the rate of precipitation, rain can be divided into different categories. Very light rain describes rainfall with a precipitation rate of less than 0.25 millimeters or 0.0098 inches per hour. Light rain is the rainfall which falls at the rate of 0.25 millimeters or 0.0098 inch to 1 millimeter or 0.039 inch per hour. Moderate rain describes rainfall with a precipitation rate of 1 millimeter or 0.039 inch to 4 millimeters or 0.16 inch per hour. Heavy rain describes rainfall with a precipitation rate in between 4 millimeters or 0.16 inch or 16 millimeters or 0.63 inch per hour. Very heavy rain terminology can be used when the precipitation rate is between 16 millimeters or 0.63 inch and 50 millimeters or 2 inch per hour. Extreme rain can describe rainfall with precipitation rates exceeding 50 millimeters or 2 inch per hour. Now, we will observe the influence of topography on precipitation pattern. Let's start with the example of precipitation pattern of hilly region. Mountains have a strong influence on the atmosphere. They alter the flow of air and respond to solar radiation differently than the surrounding atmosphere. As a consequence, in mountainous environments, precipitation is enhanced in some regions and decreased in others. One familiar example is the rain shadow, which is a region of low precipitation in the lee of topography. The interactions between topography and the atmosphere can produce spatial differences in precipitation which can influence geomorphology directly. Precipitation is considered as a fundamental driver of erosion processes and exerts a strong control on ecosystem distributions, which suggest the importance of precipitation patterns in understanding mountain geomorphology. Now, let us discuss the effects of the climate change on precipitation patterns worldwide. Global warming is considered as one of the major causes for climate changes in the world. As the Earth's climate continues to change, precipitation patterns are expected to change as well. According to the Intergovernmental Panel on Climate Change, as climate changes, several direct influences alter precipitation amount, intensity, frequency and type. Some areas may experience droughts while others experience high rainfall and even flooding. Changes in precipitation will be largely attributed to the increased water holding capacity of the air. For every 1 degree Celsius increase, the atmosphere can hold 7% more water vapor. A higher moisture capacity is expected to lead to more intense precipitation events. A warmer climate will lead to higher risk of both drought and flooding. Increasing temperatures tend to increase evaporation, which leads to more precipitation. Let's get an idea of change in precipitation amount all over the world. Precipitation has generally increased over land north of 30° from 1900 through 2005, but has declined over the tropics since the 1970s. Eastern portions of the North and South America, Northern Europe and Northern and Central Asia have become wetter. The Sahel, the Mediterranean, Southern Africa and parts of Southern Asia have become drier. The increase in number of heavy precipitation events over many areas as well as an increase in prevalence of droughts, especially in the tropics and the subtropics, has been observed during the past century. It is believed that change in patterns of precipitation will be having a diverse array of impacts on various sectors of every nation, which will include agriculture, water resources, coastal marine habitats and health of the living organisms. Droughts will decrease agricultural production and may increase the need for crop irrigation. These problems may be especially difficult for islands with limited fresh water. Many communities in the Pacific Islands region suffer from stressed and vulnerable fresh water resources. Increases or decreases in precipitation could make these problems worse. Flooding may contaminate fresh water with seawater, and droughts will deplete supplies. Runoff from high rainfall events can damage marine habitats in several ways. It may contain nutrients from fertilizers which can decrease oxygen content and trigger algal blooms. Runoff may be also contain sediments from eroded landscapes which can smoother sea grasses and coral reefs. High levels of runoff can also increase turbidity, lowering light penetration to subsurface waters. Droughts and floods adversely affect health directly through injuries and fatalities and indirectly through deterioration of water quality and quantity. Thus, we can say that maintenance of precipitation pattern is essential for healthy survival of all the living organisms on this earth.
In this part of ecology, we have got the basic idea of precipitation as the condensation product of the atmospheric water vapor. Then we have mainly focused on the different types of precipitation, in which we have learnt rain and drizzle as a form of liquid precipitation. We have also seen freezing drizzle and freezing rain, and then we have moved on to the frozen precipitation, in which we have understood snow, ice pellets, hail, graupel and diamond dust. Today, we have also got an overview of mechanism of precipitation. During this lecture, we have also studied measurement of precipitation intensity and influence of topography on precipitation patterns in brief. At last, we have understood that global warming can lead to change in precipitation pattern, which in turn affects agriculture, water resources and health of the organisms.